In this video, we're going to get an introduction to our next unit, which is systems of equations. We're going to learn 3 methods for solving systems of equations over the next several weeks, and the first method we're going to look at for this video is solving systems by graphing. So let's go over some vocabulary first of all. First thing we want to talk about, what is a system of equations? We define a system of equations as 2 or more equations put together. So 2 or more equations put together. In Algebra 1, we'll just deal with 2 equations for all of our problems. When you get into Algebra 2, you might start seeing 3 equations put together. But for these problems, we'll just focus on the 2 part of this, 2 or more. The solution to a system of equations is any ordered pair. Okay, and think about what an ordered pair means. Ordered pair means you have an x and a y value. Okay, so any pair of numbers that makes both equations true. Any ordered pair that makes both equations true. And so, like I said earlier in the video, we're going to look at 3 methods for solving these systems. The first method we're going to look at today is graphing, and then over the next 2 videos we're going to look at 2 other methods, substitution and elimination. But this video is only going to focus on this first method, which is graphing. Okay, so let's take a look at the steps to solving a system of equation by graphing. So when you're solving a system first of all is going to look something like this. Okay, just 2 equations, one right on top of the other. And we use this little brace symbol just to represent that this is one problem. It's one system of equations. And so your first step when you're solving by graphing is you want to graph both equations on the same coordinate plane. And if you look at both these equations, they should look somewhat familiar to you. These are both lines, okay, both linear equations, and they're both in slope-intercept form. So we already know how to graph equations in slope-intercept form. Let's review how to do that just with that top equation. So I've got the equation y equals x plus 2. You know for the equation y equals x plus 2 that it has a slope of 1 and a y-intercept of 0, 2. Okay, so if I graph that line, I'm going to start on my y-axis at 0, 2. And my slope is positive 1, so I'm just going to move up 1, right 1 a few times. And then I can also go down 1, left 1 for a slope of positive 1. Now it's really important that when you're doing systems by graphing that you use a ruler, and you're going to see why here in just a second. So if you happen to have a ruler or some sort of straight edge with you while you're taking this video, that would be a very good thing to use. Okay, so let me go ahead and connect those dots, and that's what that first graph looks like, y equals x plus 2. My second graph is going to be the equation y equals 3x minus 2. So that graph, you have a slope of positive 3 and you have a y-intercept of negative 2. So for this graph, we're going to start on negative 2 on our y-axis, 2 below the origin, and we'll go up 3 and right 1. Up 3 and right 1. And the really important part of graphing a system of equations is you want to look for where those lines are going to intersect. And so obviously you can see I just made this point right here. That would be where my lines intersect. So let me go ahead and finish this line. Okay, and that intersection point is actually what tells us the solution of this system of equations. Okay, so what's special about this point is it is the only point on the entire coordinate plane, okay, the only point that lies on both this blue line and this purple line. It's the only point those two share in common. So we call this the solution because it's the only x and y value where if you plug each one in at the same time are going to make both these equations true. So at this point, let's go ahead and count to see what it is. That point would be 2, 4. And to check ourselves, just to be sure we're right, if we plug in a 4 for y into our top equation and a 2 for x, that should come out to be a true statement. So if we plug in a 4 for y and a 2 for x, we get 4 equals 2 plus 2, okay, which comes out to be 4 equals 4, so that's true. And then if we plug it into the bottom equation as well, bottom equation is y equals 3x minus 2. So plug in a 4 for y and a 2 for x. We get 4 equals 3 times 2 is 6 minus 2. You also get 4 equals 4. Okay, so that is the solution to this system of equations. 2, 4 is our ordered pair. Okay, let's go to number 2 and try another example. And so for this one, you have y equals 2x plus 4, y equals x plus 2. If you'd like to, go ahead and click pause and try this one on your own, just to see if you can do this after seeing number 1. And then once you're done with that, click play to check your answer. Okay, so for this problem, we get a solution of negative 2, 0. So my first line, I put it in blue, has a slope of positive 2, a y-intercept of 0, 4. And you can see that line over here. My second line, which is in purple, has a slope of positive 1, a y-intercept of 0, 2. And you can see that line here. They cross at negative 2, 0. And so that means that's the only point that lies on both those lines. So that's the only x and y value that make both equations true. And I checked that by plugging in a negative 2 for x and a 0 for y in both equations. And when you're checking, you do have to plug it into both equations. You can't just do the top and stop. You have to plug your ordered pair into the top and the bottom equation both. Okay, let's look at number 3. This one, we're going to do the exact same thing, except you'll notice that our equations are not in slope-intercept form. They're both in standard form, so the first thing I'm going to do is change both of these equations to slope-intercept form. And so negative 2x plus y equals negative 1. That's my top equation. If I add 2x to both sides, that's going to give me my slope-intercept form of y equals, that would be 2x minus 1. So that means I have a y-intercept of negative 1 and a slope of positive 2. So I'm going to go up 2 and right 1, up 2 and right 1, left 2 and, or down 2 and left 1. Okay, so that line will look like this. And then my second equation is also in standard form. Negative 4x plus y equals negative 7. For that one, I can add 4 to both sides. And that gives me y equals 4x minus 7. And so I would start down here at negative 7 and go up 4, right 1, or down 4, left 1. And here's what your second line looks like. Now while you're doing these lines, again, keep in mind, make sure your lines look the way they should. So positive slopes, make sure your lines are increasing. Negative, make sure they're decreasing. This system, you can see the two lines cross at, it looks like, the point 3,5. So that means if we plug a 3 in for x and a 5 in for y into the top equation, that should check out. Okay, so negative 2 times 3 is 6, and then when we add in, or negative 6, and then we add in 5, that gives us negative 1. So that works. And then when I check in the bottom equation, I'm going to do negative 4 times 3 plus 5, and that should give us negative 7. So negative 4 times 3 is negative 12, and then plus 5 does come out to be negative 7. Okay, so get in the habit of checking your answers by plugging in to top and bottom equation each time. Okay, the last thing I want to talk about in this video is what are called systems with infinitely many solutions or systems with no solution. And a system of equations with no solution, if you think about that, the solutions are where the two lines intersect or where they cross. So if a system has no solutions, that means that the lines don't cross. And lines that don't cross, we call those parallel lines. Okay, so a system of equations with no solution would look something like this. Okay, two lines that are just parallel and that never ever touch. The kind of the opposite of that is a system of equations where there are infinitely many solutions. Okay, meaning that the lines cross at more than one point. They cross at infinitely many points, and that would be a system where the lines are actually one right on top of the other, and they're actually the same line. And so you'll see an example of each of these as we do 4 and 5. So number 4, we have y equals 3x plus 2 and y equals 3x minus 2. So if I do the first equation, y equals 3x plus 2, my y-intercept is positive 2, and my slope is 3 over 1. And so that line looks like this, and then my bottom equation has a slope, or has a y-intercept of negative 2, but it also has a slope of 3. And because these lines have the same slope, you can also see this from the graph, that means that those lines are going to be parallel. They're never ever going to touch since they're going up at the same rate the entire time. And so because these lines are not going to touch, we call this a no solution. But keep in mind they have to be parallel lines and they have to have the same slope. If the lines have the same slope, they're automatically parallel, and so then you know that that's a no solution. Okay, and then number 5, these lines right here, well, if you change the top equation, which is in standard form, to slope-intercept form, so we have 3x plus 4y equals 12. If you subtract your 3x from both sides, you get 4y equals, that would be negative 3x plus 12. And then we divide everything by 4. You're going to see that that comes out to be y equals negative 3/4 x plus 12 over 4 is 3. That is the exact same equation as your second equation here. Y equals negative 3/4 x plus 3. So even if we go to graph, this top one here has a y-intercept of 3 and a slope of negative 3/4. So up 3 left 4 or down 3 right 4. That's the graph of the first line, but the graph of the second line is going to be exactly the same thing, because we're going to go to y-intercept of 3, up 3 left 4, down 3 right 4. So really, it's one line on top of another line, and those lines are going to be intersecting at infinitely many points. They're intersecting at every single point you can think of on each of those lines. And so if that's the case, we call that an infinitely many solutions. Okay, so if you need to, go back through and watch any parts of the video that you were confused on. Again, make sure you're writing down at least one question per video, just somewhere in the margins on this video, and that way when you come to class next time you can have something to discuss when we talk about this a little more. Until then, have a nice day. You're all wonderful people.